Hello, we are discussing about GATE 2008 ECE paper. Look at the signal flow graph given for a system and what can be the set of equations that corresponding to this signal flow graph. We are going to write the corresponding signal flow graph equations for the given signal flow graph. Okay, that is state space equations we are going to write for the given signal flow graph. So there are four options are given, you have to choose the right one. So first of all, we should know about the Laplace transform. We know if x of t is going to be a signal in time domain, after taking Laplace transform it will be represented as x of s. If the x of t is going to be gets differentiated, that is dx of t by dt, which is also represented as x dot. Okay, x dot of t or simply x dot. If you are applying this one, then it will be for 0 with 0 initial conditions. With 0 initial conditions. Okay, Laplace transform with 0 initial conditions, then it will be represented as s into x of s. So if the in time domain signal is gets differentiated, in frequency domain it will be multiplying with s. The frequency domain equivalent will be multiplying with s, that is equal to differentiation of time domain signal. Similarly, if you are going with integral of x of t, then this will be equal to multiplying with 1 by s of x of s. Okay, so integration means simply if you are going with 1 by s of x of s means you can understand in this way. Let us assume there is a system which integrates a given input signal. Okay, if you give x of t, then you will get integral of x of t as the outputs. In frequency domain, that integration will be equal to 1 by s, such that you are applying the equivalent frequency domain signal of x of t, that is x of s. Next you are going to get it as 1 by s times of x of s. Instead of x of s, you can give any signal for this integrator. So let us assume you are giving differentiation of x of t signal, that is now you are applying d by dt of x of t, then d by dt and integration will get cancels, so that you will get only x of t at the outputs. That is equivalently in the frequency domain, differentiation of x of t means that is represented as s into x of s, and if it is applied to an integrator, then you will get s into 1 by s will get cancelled, s into 1 by s into x of s, ss get cancelled, so you will get it as x of s itself. So for integrator if you give differentiation, that is d by dt of x of t, then you will get x of t only. So finally we can conclude like this. For integrator, if you give x dot of t, then you will get x of t as the outputs. Output of 1 by s block is nothing but simply x of t if the input is differentiation of x of t. So this concept we are going to use while drawing the set of equations for the given signal flow graph. Okay, so if the nodes are going to be different nodes, you can use the suffixes for x, x1, x2, x3. So we will go for this one. How many 1 by s's are there for the given system, that you have to check, and later then we are going to write the nodes, and then we are going to write the expressions. Okay. Sorry. So this is a signal flow graph given. That I am going to use. Now I am going to write the state space equations for this one. Okay. Look at this one. So how many 1 by s terms are there? That you must identify first. This is 1 by s, and it is one more 1 by s. This is one more 1 by s. That is 3 integrators are there. Okay. So now 3 integrator means 3 nodes, and 3 nodes we are going in this way. This is first node. Let us assume input for this one is differentiation, we will assume, and the output is nothing but simply x1. And this is second node, second 1 by s, which is x2 dot, input for this one, so that output is simply x2. And this is third 1 by s, the input for this one is this node, which is x3 dot, and it is x3, output is x3, because after integrating, differentiation integration get cancelled, so you will get the original term x3. And we will assume that one, this is u2 and it is u1. It is given u1 u2. Assume that one u1 u2 are going to be input signals, and x1 x2 x3 are going to be the state variables. Okay. Now we need to write the state space equations by considering only incoming arrows at that nodes. So we are going to write the equations for x1 dot as well as x2 dot as well as x3 dot. For these nodes we are going to write the state space equations, which are nothing but differentiation of x1, differentiation of x2, differentiation of x3. Okay. So from this one we can conclude the right answer. So these node equations can be written by considering only incoming arrows. Remember that one. By only considering incoming arrows, you are going to write the expressions. So first we are coming for x1 dot. x1 dot can be obtained by considering the incoming arrows. Incoming arrows, first it is coming from, okay, this is incoming arrow, which is minus gamma into x1. So you can write it as minus gamma times of x1, and there is no relation with respect to x2, only the other incoming is from the x3, that is beta x3 plus beta x3, and one more is from the u1, so plus u1, and x2 dot is this one, and for this one only 2 incoming arrows, so you will get only 2 terms. So 2 incoming arrows, first one is with respect to x1, that is gamma x1, second one is from the x3, so this is plus alpha x3. Next x3 dot, here how many incoming arrows? 1, 2 and 3. 3 incoming arrow means 3 terms you will get. So we will start from the x1, that is minus beta x1. Next x3, because x2 is no relation, so that minus alpha x3, and this is input u2 plus u2. So now I am going to write x1 dot, x2 dot and x3 dot in a matrix form with respect to x1, x2, x3 plus with respect to u1 and u2. Now look at this one, x1, x3, x2 term is not there, and x1 is multiplying with minus gamma, so it will be minus gamma 0 and beta, so that minus gamma x1 plus 0 plus beta x3 you will get, and u1 you are writing, u1 is 1 0. Next for x2, x1 gamma and x2 0, x3 is alpha, and there is no u1 or u2 term, so it will be 0 0. Next for x3, minus beta x1 minus alpha 2 is not there, so it will be 0, alpha 3 is minus alpha, and this is u2. u2 means this is 0 1. So this is going to be the right answer for the given question. So which is equal to the D option. D option is going to be the right answer as you have solved this one. But you may get a doubt. Okay, but you may get a doubt like this. Instead of choosing in this way, if you choose it as this may be x1 dot and it may be okay, x2 dot, and this may be x3 dot. Then what happens? How do you find the answer? Okay, and these previous I have chosen according to the answer, but what happens if you choose in this way? We don't know how to choose. So assume that one we have chosen in this way, x1 dot, x3 dot, x2 dot. So now I will write the equation. Okay, so x1 dot is equal to, this is x1 dot and now it will become x1. This is x3 dot, it will become x3, and this is x2 dot. Same we are going with x2 dot and it is x2. Okay, so x1 dot is equal to, x1 dot is this one. Consider all incoming arrows and make it as, you can go for the u1 and u2 here. Okay, all changes we are taking. x1 dot is equal to, incoming arrows only you have to consider while writing. So this is first one, minus alpha x1, minus alpha x1. Next from x3, minus beta x3. Consider only red color. Okay, plus u1. Next x2 dot is equal to, x2 dot is this one, x2 dot is equal to minus alpha x1, sorry, plus alpha x1. Okay, this is positive, so alpha x1, and this is gamma x3 plus gamma x3. Okay, and there is no u term because it has only two incoming arrows. Next you can write it as x3 dot is equal to, x3 dot is this one. So consider the incoming arrows. Incoming arrows from the x1 we will start from. So this is beta x1, next minus gamma x3 plus u2. So from this one if you write x1 dot, x2 dot, x3 dot with respect to x1, x2, x3 plus u1, u2. Now x1 minus alpha 0 minus beta, and this is alpha 0 gamma. Next beta 0 minus gamma, and u1 is present for x1. So this will be 1 0 0 0 0 1. Okay, now identify this one. You will get the same matrix, that is this A matrix. Generally it will be in the form of x dot is equal to ax plus bu. So this will be the A matrix and it will be the B matrix. You will get the same A and B matrix. Whatever the nodes you have chosen, you will get the matrix. That matrix A and B will be having the same elements. That is same rows. Maybe rows become interchanged, but you will get the same matrix A. Look at this one. Okay. So if you observe minus alpha, alpha, beta, minus alpha, alpha, beta, and this is 0 minus beta, 0 gamma, 0 minus gamma. So simply the values are, okay, beta 0 minus alpha. This is interchanged like this, beta 0 minus gamma. Okay, rows as well as this is row as well as columns are interchanged, and gamma 0 alpha, gamma 0 alpha you're getting the same. And next minus alpha 0 minus beta, minus alpha 0 minus beta, and for this same beta 0 minus gamma you will get 0 1. This 0 1 is also interchanged because you have taken u2 u1, so this value you are getting. And for the same one alpha gamma, gamma 0 alpha, you will get 0 0. That 0 0 is going to be true. Okay, and for this minus alpha 0 minus beta, that is for the first one, it is 1 0, and you will get it as 0 1 because u1 u2s are you have taken differently, exactly opposite. Okay, whether you have chosen according to x1, x2, x3 in any manner you can choose, but you can check that one, the A matrix and B matrix what you got is going to be matching with the answer or not. So if you are going with this one, then it will be matches in this way. So look at this one. Now we will match this. Now for this one, minus gamma 0 beta. Okay, minus gamma 0 beta. Minus gamma 0 beta means third row. Third row, that is we have taken it as x3 dot. Okay, so you are getting x3 dot, but previously you have taken it as x1 and x3 interchange, so that now you are getting in different places. Okay, but the values are going to be, you don't get any other values. If you observe, all the three a values are going to be different. That will be matching only with this answer. Okay, so it is not the matter how you are going to choose the nodes. You can always find the right answer by comparing that A matrix and B matrix with the corresponding answers. So the right answer for this question is D itself. Thank you.